In our maths today, we shall look at multiplying and dividing by an integer. Multiplying and dividing by an integer. But before we go into that, I want us to remind ourselves about our previous lesson that we covered previously concerning adding and subtracting negative integers. Adding and subtracting negative integers. The previous lesson, we saw that it is known that when we are adding, a point note is that when we are adding a negative integer, for example, take A, add a negative integer like B, we said it is the same as just saying A minus B. So when you are adding a negative integer, it is the same as just taking the number, subtracting that integer. And in case you are subtracting a negative integer, then you'll find that it is the same as taking the integer, adding to the other integer. So these two cases can be proved when we are using the integers. Take, for example, 2 plus negative 3. 2 plus negative 3, using the first principle that we have here, it will be 2 minus 3, which can be found as negative 1. For the second illustration, if you have 2 minus negative 3, this one is similar to the second illustration. This will be the same as 2 plus 3, which gives us 5. So this is how we add and subtract negative integers. So looking at this question, evaluate negative 90. We are to evaluate negative 90 plus 50 minus 138 plus 35. That is what we have. Minus 90 plus 50 minus 138 plus 35. This question that we have, we find that this question here involves several negative and positive integers, but because both are plus and minus, so we work on them as they come. So minus 90 plus 50 will give us minus 40, and then we take minus 40 minus 138. So this one here is minus 40. So minus 138 plus 35. Then this one here will give us minus 178 plus 35. And that one will give us negative 143 minus 143. So we've been able to use both positive and negative numbers. Similarly, we can also be able to have statement questions that require us to use both negative and positive. Take, for example, another quiz. A diver is at a height of minus or negative 90 meters from the surface. From the surface of the sea. During a diving exercise, the diver rises 50 meters, falls 138 meters, falls 138 meters, and then rises once again by that 5 meters. So the question here is, what is the diver's final height? What is the diver's final height? What is the diver's final height? The question here requires you to identify the heights at each level that the diver was making. So we first find that initially the diver is at minus 90 meters. And then, during the exercise, the diver rises 50 meters. So, there is a rise of 50 meters, which is a plus because he's rising up. Later on, he falls to 138 meters, which means that when he falls, he will go minus 138 meters further below. And finally, he rises once again to 35 meters, which is a plus. So having noticed this, then we can simply agree that the final position of the diver will be minus 90 meters plus 50 meters minus 138 meters and then plus 35 meters. So he was below 50 meters when he rises, 90 meters when he rises to 50 meters. It means that what is remaining is just below by 40 meters. So this one will give us 40 meters minus 138 meters plus 35. This two gives us 100 minus 178 meters plus 35, and you'll find that what you are getting is minus 143 meters. So when he rises up, this is the position. Now, let us look at the rules of multiplication. Now, in the rules of multiplication, this can be noticed when we take a few integers and we practice with them here and see how they behave. You'll realize that when dividing or multiplying, the rules here can be developed when we consider this. Take, for example, 4 groups of negative 3. Take 4 groups of negative 3. 4 groups of negative 3 here means negative 3 4 times. Negative 3 4 times. So this is the same as saying negative 3 plus negative 3 plus negative 3 plus negative 3. Negative 3 4 times. You'll find that this will give us negative 12. When you look here, I said 4 groups of negative 3, which implies that we can also rewrite this as 4 times of negative 3. That is 4 groups of negative 3. And the answer here, when you take 4 times or multiplied by negative 3, you will get negative 12. Also, if we interchange this and say negative 3 multiplied by 4, you'll be able to get negative 12 from the principle that says A times B is the same as B times A. There's no difference. When you take 5 times 7, these are all positive integers, it will give us 35. Then for this case, we can say that 35 divided by 7 is 5. Therefore, 35 divided by 7 is equals to 5. It is a true statement. Now, if this is the case, our earlier illustration was telling us that if you take 4 multiplied by negative 3 will give us a 12 negative. Then we can agree that it is true if we take negative 12 divided by negative 3, it should give us a 4. Or negative 12 divided by 4 should give us negative 3. Looking at this, you realize that when we were dividing or getting the quotient of two negative numbers, the result was positive. When we are getting the quotient of a negative number and a positive, the result is negative. So this can bring us to the rule that govern multiplication and division of integers, which simply says that when you are multiplying both multiplication and division, we can conclude and say that when multiplying integers with the same sign. When multiplying integers, let's say two integers with the same sign, then the result is positive. What I'm trying to say here is this: minus 2 times minus 4. The sign here is negative 2, the sign here is negative 4. We have negative and negative. From this, the result must be positive, so the answer is supposed to give us a positive 8. Similarly, if the signs were positive, it would be just 2 times 4, which is 8. But when multiplying two integers with different signs, the result is negative. When multiplying two integers with different signs, the result is negative. For example, 3 times minus 5. 3 times negative 5 will give us, because the signs are not the same, this will give us negative 15. And when we are dividing or getting the quotient of the numbers, the same applies. When the quotient of two numbers, with same sign, so I want to say that, let us make it a statement, the quotient of two numbers with the same signs will always give us, the result will be positive. And to illustrate this, we can have 15 divided by 3. This one will give us 5. We have 5. Negative 15 divided by negative 3. This one will give us, again, 5. When we have two signs that are the same, the result is positive. Take note that 15 divided by 3 is the same as 15 over 3. There's nothing wrong when you write it like this. It's a quotient, so it can be applied. However, when the two numbers are not with the same signs, but the signs are different. So the quotient of two numbers with different signs we shall find that the result will be negative. A good example here, 12 divided by negative 3 is negative 4. Positive and negative is negative. Negative 12 divided by 4 will give us negative 3. Negative, positive will give us a negative. That is the rule. So I want us, using what we've gone through, I want us to fill the table and see how we can apply the rule of multiplication and division of integers in this particular case. Okay, looking at the board here, I want us to fill this table. We are multiplying. And as we multiply this, I want us to fill this table, considering that the multiplication is between what is on the horizontal and what is vertical. For example, a 0 and a 0, when you multiply 0 times 0, you'll get a 0. 0 times negative 3 is 0. 0 multiplied by negative 2 is 0. 0 multiplied by 1 is 0. So 0 multiplied by any number will always give us a 0. That's why we have this this horizontal row with zeros and this column also with zeros. For example, again here, 1 multiplied by 1 is 1, and 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. So, can we fill the rest of the table and see? Applying the rule of multiplication. Negative 3 multiplied by negative 3, the two of them are both negative, so the answer should be positive, so this one is a positive 9. Negative 3 times negative 2, this one will give us a positive 6. Negative 3 and negative 1 will give us a 3. Negative 3 times positive 1 is negative 3. Negative 3 and 2 is negative 6. Negative 3 and positive 3 is negative 9. Let me take the one for 2 here. Positive 2 times negative 3 here will give us negative 6. Positive 2 times negative 2 will give us negative 4. Positive 2 times negative 1 will give us negative 2. Positive 2 multiplied by 1 will give us a 2. For the 2 we have already been given 4, and for 3 will be 2 times 3, which is a 6. You will notice that the rules in this case are applying. Now, I want you, during your free time, to complete this table, observing the rules very carefully. Then you'll notice that there are those areas which will have the positive results. Other side of the table will be filled with the negative results. Having said this, take note that the product or the quotient of two numbers, the product or the quotient of two numbers of the same signs, either positive or negative, is a positive number. I'll illustrate this using some signs and numbers. Any quotient or any product of two numbers with the same signs, that is either positive or negative, the result should always be positive. What am I trying to say here? Taking any number, if we say A, which is positive, multiplied by B, which is positive, or negative A multiplied by negative B, the signs are still similar. The answer should be just positive, that is A, B, A, B. That's the rule that says when taking the quotient or the product of two numbers with like signs or the same signs, the answer should be positive. Also, take note that the product or the quotient of two numbers of opposite signs, two numbers of opposite signs, that is, opposite sign, we have the numbers have either positive, they have positive and, not or but and, negative. If we have two numbers, one with positive, another one with negative, or another one with starting with negative and then positive, then the result will be negative. For example, negative A multiplied by B is negative AB. If it was for the quotient, minus A divided by B is minus A over B. So the result will always be negative. So let us look at worked out examples as we apply the rules that we've gone through. Calculate the products and quotients of the following. Calculate the product and the quotient of the following. A, we have 5 times negative 6. B, we have minus 3 times negative 7. C, we have negative 36 divided by negative 4. And D, negative 18 divided by 9. So we have 3 problems. Calculate the product and the quotient of the following. A and B is calculation of the product. C and D is calculation of the quotient. So in our solution, we shall go step by step. The first one in our solution, 5 multiplied by negative 6. So this one is 5 multiplied by negative 6. We shall find the answer is 5 times 6 is 30. But the rule says the two numbers don't have the same signs, so the answer should be in negative. That's the first thing we should just notice. The answer should be negative. So it's negative, and then 5 times 6 is 30. To explain this, we say that the numbers are of different signs. The second one is negative 3 multiplied by negative 7. Negative 3 multiplied by negative 7. The signs are the same. Both of them are negative. The rule says simple. If we are multiplying two numbers with the same signs, the answer should be positive. So irrespective of the number we are dealing with, the answer is positive. So we know that the answer is positive, therefore we just multiply 3 multiplied by 7, you'll get 21. Then to explain this, we shall say that numbers are of the same signs. The third one is a quotient. So for the third one here, it is asking us to find negative 36 divided by negative 4. This is the same as negative 36 over negative 4. The two have similar signs, so we say that if the signs are the same and we are getting the quotient, then it means that the answer should be positive. So definitely here, because we know the answer is positive, take 36 divided by 4, you'll find your answer as 9 when you simplify. And to explain this, we are taking the quotient of two numbers with the same signs. It is positive because the numbers are of same signs. For the last one here, when you look here, just identify the first number has a negative, the second number is positive. The rule says when two numbers have opposite signs, the answer should be negative. So for this, negative 18 divided by 9 is the same as negative 18 over 9, which will be negative, and the answer you'll get, which will be 2. And again, you give a reason why have we settled for negative 2. We say it is because the numbers have opposite signs. So let us now change to the order of operation with positive and negative integers. Order of operations with positive and negative integers. The order here applies in mixed operations. And in such situation, you'll find brackets coming in and all numbers and so on. So when you talk about the order of operation, we are looking at a situation where we have mixed numbers. Take, for example, negative 2 plus 3 times negative 4. This is not the same as negative 2 plus 3. Then we put in bracket times negative 4. I want you to see this very clearly. The numbers looks alike, but I'm saying that the first operation and the second operation are not the same. Why am I saying that? This one is 2 plus 3 times negative 4, which will mean it's 3 times negative 4 first, and then that is minus 12. Minus 12 plus negative 2, you'll get this one, giving us negative 14. While this other one, it is 2, negative 2 plus 3, which is positive, which is, this one will give us positive 1, and then multiply by negative 4, it gives us negative 4. So the two are not the same. So the moment you introduce brackets in a problem, then the brackets changes everything. I want you to discuss this. Discuss with your colleague 3 times negative 4 minus 8 divided by negative 2, and it's telling us the answer is 8. Discuss it. So in your discussion, you should have noticed some feel like this is impossible. It cannot be done. Maybe because we don't have the brackets. If we had the brackets, we would work on it. Another one we must have also felt that even if we introduce the brackets, it is impossible to do it. So we leave it. Maybe another one has felt that there is no need of brackets. We can just work out and get the answer without working out the brackets. So, which is which? By the end of this lesson, you should be able to work out such problems without any problem, keeping in mind that you maintain the order of operation. And how do we solve such problems if we don't know the order of operation? Now, when working with more than one problem, so we are going to tackle this problem having looked at the order itself. And I want to say this, the facts that we must consider. When working with more than one operations with positive or negative numbers, 1, deal with brackets first. Deal with brackets first. 2, do the multiplication or division next. That is immediately after the first working. Now, having done all that, and I want you to notice this. In this case, do the multiplication and the division next, but starting from the left. And 3, do the addition or the subtraction, and this one should come last. And as you do it, you should always remember working or starting from the left. Those are the rules when you are dealing with a problem that has several operations. So I want us to look at various problems, and remember, we should apply and do the first of dealing with the brackets first, then we move to the next step. If it has it, do the multiplication or the division next, starting from the left, and finally the addition and subtraction comes in last, but still starting from the left. So let us work out this. -2 times 3 minus into bracket 10 plus -2 divided by 4. Now, our solution here, this is the problem. Now, when we go to the solution, when we look at the solution for this, we are told here that deal with the brackets first. So where do you have the brackets? The brackets are here. So I'll expect you to first deal with the brackets. So this is the first. So 10 plus negative 2 is the same as 10 minus 2, which will give us 8. So that is the first. Do we have any other brackets here that are remaining untackled? Let's see. We don't. Then, do we have either multiplication or a division? Let's see. Yeah, negative 2 times 3 is here. We have a division the other side. So, what follows? So, we find that we shall come to division or multiplication, but the rule says that starting from the left. So we move to the left. If there is a multiplication there, we start with it first. If there is a division there, we start with it first. So what we have here is a multiplication here. So this is the second operation. Negative 2 times 3. It is a negative and a positive. The other should be negative. You'll find that this one will give us negative 6. Have we exhausted multiplication? No. Have we exhausted division? We can't conclude unless we look at it. So multiplication, none, but division, it is there. So we shall need to go into the third operation here, because it is the result here, divide by that. So if we do that, 8 divided by 4, both of them are positive, it will give us a 2. So we are done with the third. We want to go on and finish. So no more multiplication, no more division. The last step will be this. That is the fourth step, and I think the last. Negative 2 minus 2. Negative 6 minus 2. You'll find that minus 6 minus 2 will give us negative 8. So you can simply conclude and say the problem that we have here, our answer is negative 8. We have exhausted the brackets. We have exhausted the multiplication, the division, the addition, and the subtraction. Now, in this question, use the order of operation to evaluate. Use the order of operation to evaluate. We have two problems here. Use the order of operation to evaluate the minus 6 times 2 minus 10 divided by negative 5. From the first one, we don't have brackets, so we shall not deal with brackets. They are not there. So move the second step, multiplication and division, starting from the left. So we shall first, this is our first operation, this is our second operation. When you find negative 6 times 2 will give us negative 12, and 10 divided by negative 5. 10 divided by negative 5, you will find that this one will give us a negative 2. It will give us a negative 2. No more multiplication and so on, so you will remain with negative 12 minus negative 2. This one is the same as negative 12 plus 2, which gives us negative 10. So this is our answer. So you'll notice that here we multiplied here and then we did the division. Then after that we came to addition and subtraction, if any, and we resolved to settle on our answer. Let us look at the second one. It has got brackets, and the rule says when you have brackets, you start with the brackets first. So definitely from here, we shall handle the brackets. Our solution, we shall start from here. So we shall maintain 5 divided by minus 10 plus 5. Minus 10 plus 5. This one will give us negative 5. And then at the end plus 5. That's what we have. We move to the second step, which deals with multiplication and division, if it's there. This one we don't have multiplication, but we have division. So we shall come to 5 divided by negative 5. It's a positive divided by a negative, so the answer should be negative. So 5 divided by 5 is 1, so we shall have negative 1, and then plus 5. Negative 1 plus 5 gives us positive 4. So the answer there is a 4. Another problem of similar case is this. This is number 3. Negative 6 minus 10 plus 2 over 3. Minus 6 plus minus 6 minus, or negative 6 minus 10 plus 2, all of it over 3. Now for this particular case, here we said earlier on that dividing a number is the same as getting the quotient, or is just like taking a number of another one, which is like a fraction. So in this case, it will mean that we actually simplify the fraction first, which implies that we shall simplify the 10 plus 2 divided by 3. When you work out that, you'll find that this one will be rewritten and it will be negative 6 minus 10 plus 2, which is 12 over 3. This one will give us negative 6 minus 10 over 3, minus 12 over 3, which is 4. This one will give us negative 10. So for this case, it was necessary that we identify there is a fraction we are dealing with, and we remove the fraction by simplifying it, and we come to settle on that. Let's look at another problem involving fractions. One, that is number D, 1 minus 2 times negative 3. All of it over Negative 3 minus negative 2. This, it is involving fractions, and anything involving fractions, we need to simplify the fraction first. So we shall first deal with the fraction. So this one remain 1 minus 2 times negative 3. They are different signs, so this one will give us negative 6 divided by, here we have 2 minus negative 2. When we say 2 minus negative 2, it is the same as, sorry, when you say negative 3 minus negative 2 is the same as negative 3 plus 2. So this one will give us the denominator as negative 3 plus 2 is negative 1. So we have a quotient here. That is negative 6 over negative 1. The signs are alike. The numbers are simple to divide. So 6, because negative and negative gives us a positive, so we shall maintain a positive, and then 6 divided by 1 is 6. So we shall have 1 minus 6. And when we subtract that, our answer will be negative 5. So with this exercise, it brings us to the end of the lesson. And I want to believe by now you should not have any problem when you are handling or multiplying or dividing any integer, whether be it positive or be it negative. And also, I believe by now you are comfortable, you are able to use the order of operation to evaluate various problems. Thank you.